Alright, hey guys, my name is Joseph Jimenez. I am doing problem 18 from chapter 9. It's kind of a dumb problem because it has 3 parts, which really should count as three questions, but it doesn't. So what it is from the bio section. It says the flowers of the bunchberry plant open with astonishing force and speed, with pollen grains accelerating from rest to 7.5 meters per second. So question A is, what impulse is delivered to a 1 times 10 to the negative 10th kilogram pollen grain? The second one is, what is the average force if this impulse is delivered in 0.3 milliseconds? And C, the third one was, how does this force compare to the weight of the pollen grain? So I'm going to refer to the 3 equations that I used to be able to solve the problem, which really helped, and it had a lot to do with the last problem I did, which was problem 6. Okay, so the 3 equations I used were, the first one denotes that the impulse is equivalent to the change in the momentum, which is going to come in handy, as well as I use that momentum is equal to mass times velocity, and then also that impulse is equal to the force average times the change in time. And we're going to use this as well as what was given to us in the problem. So firstly, we have our mass, which was 1 times 10 to the negative 10th kilograms. The other was our initial velocity, which was 0, and then it ends up going up to 7.5 meters per second. And then our change in time was 0.30 seconds. So from that equation, from all the equations I wrote and with the knowns, what we're going to do next is find the impulse. And to do that, we're going to use the that the impulse is equal to mass times the change in velocity. So let me rewrite that real quick. So now we're going to use the this equation. So it's going to be impulse is equal times the mass times the change in the velocities. So with that, we have our mass of 1 times 10 to the negative 10th kilograms. And then we have our 7.5 meters per second for our final minus our initial, which was 0, which is going to give us a impulse of 7.5 times 10 to the negative 10th kilograms times meters per second. And that'll solve our first problem, which was what is the impulse. So now we're going to answer what is the average force of this impulse if it's delivered in 0.3 milliseconds.